Okay. All right. Yeah, let me start the. All right. How strong are you with statistics?
I'm not really sure, but we learned this like in methods last term.
Oh, you learned this in method. So
not standard, but oh yeah, it is standard deviation.
standard deviation.
Yeah, but
okay.
we learned it like briefly.
Okay.
Like
okay.
at the end of the term.
Mm-hmm.
Yeah, like the.
Yeah, like this one here, right?
Yeah.
The standard deviation, right?
Yeah.
Okay. Do you understand what it means by standard deviation?
Didn't really understand, but I thought like it's like how much varies from like the mean, mean or median. I'm not sure.
Mean, yes. How much it varies from the mean. Okay. So when you look at the data set, right? You could have data that has, let's say 6 points. So you could have, let's say we have like 9 points. You could have data like that where it's a bit more spread out, right? As opposed to a different set of data where you would have, most of the data point is, so it's also 9, but it looks like that. Okay, so this one has a larger standard deviation or sigma. Okay, so this one, the standard deviation will be larger than the one over here. It's just a wider spread, right? And let me tell you the computation formula. So have you learned about variance?
I don't think so.
No? Okay. Standard deviation, right? Deviation is the same as the square root of variance. Okay? Or you would write sigma is equals to square root of var of x, and x stands for any random variable. Do you know what a random variable is?
It's just x.
Not just x. Okay. We'll get to that again a little bit later. So yeah, so that's what it is. And variance, right? So without the square root, variance is the same as expected value of x squared minus the mean everything squared. So mu, this symbol, mean squared. Okay, so that's a computation formula. Now you will actually learn these two formulas in methods in unit 4, so year 12. So I'm not sure how much they have taught you at school about these concepts, but let me go through this one here, calculating standard deviation. Have you seen this table before?
Sorry?
Have you seen this table before?
Yeah.
Yeah. So just quickly recap. So this one is just take f times by x, right? So that number times by that number.
Yeah.
And then that symbol, what does that mean? This symbol here.
Mean,
yeah, right? So that would just be the x value minus the mean. So you calculate what the mean is.
Yeah.
I'm assuming you know how to do that. And this one just x minus the mean everything squared. And then this one times that in here. And then we sum all of that. That would be so they used a very strange formula here, but that will be the sum of all of that number here, which is 8, and then over 24. You see the square root?
Yeah.
The square root is from that formula I told you earlier, where the standard deviation is the square root of the variance.
Oh, so like under the square root, that's the variance?
That's the variance, yes. Okay, so in this case it will be sum of f times by the difference between each data point and the mean, and you square that over the sum of all the value, like all the f minus 1. That's basically it. Okay, so sum of all the values minus 1. So yeah, the formula, I think it should be fine. Work through these formulas. That's standard deviation. And I just explained what it is for the difference between standard deviation, like a low standard deviation versus a high standard deviation. So in your own words, give me a statement that use data set and standard deviation.
Oh, so like the definition for both?
Well, give me a statement that links the two together. Like, So a data set has low standard deviation when in what case?
Like the same age group of people that reacts to like a vaccine or something?
So what's the difference between low standard deviation and high standard deviation?
Low standard deviation is like people that act the same.
Okay.
And that high deviation, it just like varies.
Varies more. Yeah, okay. That's fine. I'll take that. Okay. So yeah, that's it. So I think standard deviation is not too hard. I won't go through too much of that. Now, have you heard of the normal distribution? No. Okay. Area under the curve and z-score, standard bell curve. Okay, all right. Let me go through the main idea of the normal distribution for you. Now, normal distribution is not something you learn in like the actual math specialist that you learn in year 11. You don't learn that in unit 1 and 2. You learn normal distribution as math methods, unit 4. Okay, so normal distribution. So technically, after you learn this topic now, you don't see that again until like about 2 years later.
Would it be like much harder than this?
Somewhat, yes. Yeah, not much harder. Yeah. If you get the main concept, it will be the same. So, you know how when, for example, if you, let's say a data set's like 3, 4, 5, 6, 6, 6, right, 7, 7, 8, for example. You can plot that on a number line. So 3, 4, 5, 6, 7, 8. And you put the dot plot, right? So one of this, one of that, one of this, and then 3 of that, and then 2 of this, and then, 2 of the 7 and 1 of the 8, right? So generally, it will make kind of like a shape that looks like that. Yeah?
Yeah.
Now, if you were to put a lot more data points, so here's only like 3, 4, 6, 9 data points. If you are to collect, let's say, the height, okay? How many people are there in your school?
Like 1,050.
1,050, let's say 1,000. Yeah. Height of 1,000 students, right? In Mount Gravatt High. State High, Mount Gravatt State High, okay? Yeah, so let's say if we collect the data of 1,000 students and we plot them in like a dot plot like that. But remember, the height is not so let me teach you a concept of a continuous versus a discrete distribution. So discrete random variable, discrete versus continuous. So a discrete is like when you roll a dice, you can count how many. Let's say you roll the dice 5 times. You count how many 6s you get out of the 5 times. All right, so the numbers are whole numbers. Yeah, you can get either 3 out of 5, which will be equal to 6s, and the other 2s are whatever other numbers, right? 1, 2, 4, whatever. So that's discrete. Similarly, if you get 10, if you randomly close your eyes, pick 10 people at school, you could get 4 out of 10 to be a male, for example, to be a male, right? So these are all discrete, they're all whole numbers. Now, continuous is a different concept where we will talk about, let's say, height. Okay, do you think anyone can have the height of exactly 100 and let's say what's your height roughly?
172.
172. Do you think your height is exactly 172?
Probably not.
Probably not. Do you think your height is 72 point, let's say if you know what it is, let's say if you go like 0.3, right? Do you think that's accurate enough?
Yeah, I think so.
Maybe, that's fair, right? But what if it's actually 0.3 and then 1 and then 4 and then 2? And if you have something that even more accurate, you can add like, or it could be 6, 7, 2, 4, whatever. It goes on forever, right? Yeah. So you see how your height is never an exact whole number, right? And what do you think a chance of someone having the exact same, like by exact, I mean like, if your height is 172.00 forever, right? 172 whole, what's the chance of someone else having the exact height 172?
Probably pretty low.
Like close to 0. So that's what happens to the continuous scale, right? You know how when you have a ruler, right?
Yeah.
Right? If this is 172, let's say it keeps going. On the ruler, it's 172. This is 173. If you have two divisions, then you can only measure up to 172.5, right? If you have 4 divisions, then you can measure up to 172.25, and then 172.5, and this is 172.75. So you see where I'm going? If you keep on dividing it, you get more and more accuracy, but you can infinitely keep dividing it. Right? So on the continuous scale, it doesn't make sense to have like a whole number on a continuous scale. So on a continuous scale, you normally want something like, what's the, so you want to go, what's the probability, PR stands probability, that the height, so H of a student at your school is between two values. So let's say between 172 and 173. Less than 173. Now this one you can't find a value for. But the probability that someone's height is exactly 172 is equal to 0. Right? As a whole number, it doesn't make sense. It will be 172 point something, something, something. So the chance of it being equal to a number is 0. But the chance of it between two heights, well, then you don't actually need something too accurate, right? You need to have like a scale here, 172 versus 173. And if someone stands between that height, right? If someone stands here, then you're like, yep, that person is, it's counted as part of this of this event, right? If someone stands higher, then they will not be part of it, right? So you only need to get them within the two range. So that's why in the continuous scale, you need to measure between two values. And that's what the normal distribution is about. So let's say if we measure the height of people in your school, right? And let's say the average height is 160, okay? Let's say the average height is 160. And so the mean is 160, right? The height of students at school, okay? So I'm using, this is hypothetical, it's not accurate, okay? So don't think too much about the numbers. And let's say the standard deviation is, I'm gonna make it up 5, okay? Now, a normal distribution, is also called a bell curve, right? Is the idea that when you set out a scale, so it starts off in the mean and then you plus 3 standard deviation. So when you plus 1, it's 165.
So the mean has to be like in the middle?
Yes. So a normal distribution is centered around the mean. So left hand side and right hand side is equal, right? So it's 50% of the people will be on the left and 50% of the people will be on the right. Yeah, that's the property of the normal distribution. And most things are normal. I'll get to that in a second. So most things in life are actually normally distributed. That's why this is a very interesting chapter. You learn the actual mathematics more in Unit 4. I think they might just introduce the idea now. Okay, so if you want to actually graph the normal distribution, right, it will be centered around the mean, but we need to go plus 3 standard deviation, 170 and 175, and then you minus 3 standard deviation, so 155, 150, and 145. The normal distribution has this property where most of the area will fall within plus and minus 1 standard deviation. Sorry, plus and minus 3 standard deviation, right? Let me just finish drawing that. So 50% to the left, 50% to the right, okay? And there is a rule called 68, 95, 99.7. So what is this rule here? I'll go through this in a second. So let's just say if this is the distribution of the people, of the height of people at your school. Now what this means is that 50% of students will have the height lower than 160. Make sense? Yeah. And then 50% will be higher. Now, this rule, this number 68 means that 68% will have a height within plus minus 1 standard deviation.
Is it exactly 68?
Good question. No, it's not exactly 68. This is an estimation. It's actually 68 point something something, 67 point something something. And the calculation to do that, you can actually do it with a calculator.
A graphics one? Or
graphics one. Do you have a graphics calculator?
No.
You need to get a graphics calculator. You need to check with your school which one you guys are using.
I think it was Casio. Yeah, the bottom one.
The bottom one?
Yeah.
Okay.
Our teacher told us to get it in year 11.
Yeah. You will have to get it in year 11. You can just get it now.
Yeah.
Because I think it's better to get it around the time when the year 12 is finishing the external. Because when they finish the external, it's like, don't want this calculator anymore. That's when you jump in the belt. Can I get it for like $20? Because this is $200.
Oh.
Yeah. Right? So if you can buy a second-hand one, much better. It doesn't matter. As long as it is, make sure it's the model FXCG50. Right? I'm pretty sure that's a model that you guys will be using. Double check with the teacher what the model is. But get it off second-hand if you can. When you wait until you actually need it, everyone needs it. And so there's no second-hand available. So get it sooner than later. Okay, so yes, you can calculate the number. It's not 68%. 68 is an estimate. All right, the actual number, you can do that with a calculator. I don't think you learn that now. You learn that in Unit 4, Math Methods Unit 4. But the rule 68, 95, 99.7 says that 68% of people will fall within, so this is mean minus standard deviation, and this is mean plus 1 standard deviation. Okay, so 68% of people will have the height between 155 and 165. Okay, and then the 95 rule, so you can probably guess it by now. The 95 rule means that 95% will have the height between plus minus 2 standard deviation. Okay, so this area here is represent 95% of the people. Okay, and then 99.7, no, it's not 100, it's 99.7. It's close to 100, but it is not 100. So 99.7% of people will have the height between mean minus 3 standard deviation and mean plus 3 standard deviation. Does it make sense so far?
Yeah, but like, would the normal distribution line touch the bottom line at any chance?
Good question. No, it doesn't.
It never touches?
It never touches. So it will always approach it. It will get very close to it. It will never touch it. All right? Because when you think about it, let's say the height of someone, right? So in some cases, like the height, you can't have less than 0 height. So it doesn't make sense. But they would just model it using the normal distribution. So the idea is that the area, so I'll just use this one to highlight, the area after these ones is really small. In fact, can you guess what it is? What's the area to the left of the number of 145? So what's the percentage of people with a height lower than 145? What do you think?
0.15?
Yes, very good, 0.15%. Okay, same here, this one will be 0.15% because it's evenly distributed. Now let me go back to the graph here. So does that graph make sense now?
Yeah.
Yeah?
Just those numbers add up together.
Correct. So you see the 68 rule in the middle is that section there, right? Yeah. So when you add 34, 34 is 68. So that's what I'm saying by the 68, 95. So 95 is these two together. So when you add up these ones, it's a bit strange that they put this one here, but when you add this to do, will be 47.5, right? And you times it by 2 is 95.
Yeah.
So remember that rule, because this rule you will have to know in Math Method Unit 4. So in this version, they're just using something that, like you probably can use this one, but yeah, but I think just remember this rule. If you can remember this one in Math Methods, it will be a little bit easier. Okay, now use table to get these values. Okay, let's see. So standard normal table. Okay, so let me introduce. So this is a normal distribution, right? The next concept is a little bit different. Is the standard normal. Okay, so the only word that's different is standard. It's still a normal distribution, but it is a standard one. Distribution. So what is a standard normal distribution? Standard means that the mean is equals to 0 and the standard deviation equals to 1. Okay? Okay, so you see how the height using our height distribution is 160 centimeters and the standard deviation is 5 centimeters, right? In the standard normal distribution, when you say standard normal distribution, it's always 0 and 1 for mean and standard deviation. Okay? So that means that if I were to sketch it, it will start at 0. Right? And it will go 1, 2, 3, 1, 2, 3. And go to the left, you will drop by minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. And the shape, well, exactly the same. Because it is a normal distribution. So it's supposed to be exactly the same. Okay, so the two sides will never touch because this is the property of a probability density function, PDF. Again, I'm introducing all these concepts, but you don't need to memorize any of this. Just focus on school, all right? Whatever you don't understand from school, I will explain those ones again. But I'm throwing these words so that it stays somewhere in your mind. I'll get to that reason in a second. So same rule, plus minus 1 will be 68%. Which is what we saw in the graph earlier. Okay, and then plus minus 2 will be 95 and 99.7. So this rule applies for any normal distribution. Standard normal distribution is still following the same rule. So if you want to find out, in using the standard normal distribution, if you want to find out what's the probability, right? What's the probability that, so the standard normal distribution, the name of that is Z. Okay? Z represents the standard normal distribution. X is normally the normal distribution, and then Z is the standard normal. So the probability that the z value is less than, let's say, 0. Running it this way is saying, okay, what's the probability that a data point will be in this section here? And that would be 0.5 or 50%.
Including those like on the left, right?
Yeah. So everything. Yeah. As I haven't highlighted everything, but yeah, it includes like everything, and it keeps on going forever. Yeah. So that probability is 0.5, right? And so if you have probability that z is between two values, let's say -1 less than z less than 1, this one will be, what do you think?
68.
68 or 0.68, right? Again, it's approximate. So approximately 0.68. Okay? Right? Then that brings me to this table over here. Standard normal table Z. Entries in the table give the area under the curve between the mean and the standard deviation above the mean. Okay, let me just snip out a bit of it. Okay, and then chuck that in. Here. Okay, so let's say we have this standard normal table here. So far, the last two examples I use whole numbers, right? Like 0 and then the -1, 1, easy. What if you have a number that is not whole number? Like, what if the area you want, the z value here is 1.25? Alright. Now, normally using the calculator, you can just, there is a way to punch it into the Casio one to get a very high accuracy one. But I think at year 10, you only just learn about the standard normal table. So how to read this table? So remember, we want the area. So here, in this example, z equals 1.25. So they're just saying that the z value is over here, right? 1.25 is around there. Yeah. And then they want the area from 0 to 1.25. Okay. They say we don't know the answer yet. So you read in here, in this table here. So you read on the left hand side first. Find closest to 1.25 is 1.2. Okay. Then you need to look at this entire row over here. Okay. Then now you look from the top here. So this one means that number is corresponding to z equals to 1.20, right? And then this one would be z equals to 1.23. Yeah, you see the pattern? Yeah. Then this one would be for z equals 1.25. All right, so then when you look down from that column, it will be the number 0.3944, which is that one here. Okay, so what they're saying is that if you can use the standard normal table to find out the probability, right, where z is between 0 and a certain number that is up to 2 decimal places.
Only up to 2, or? Yeah,
because you see this one is only up to 0.9. So for example, that number there represents probability, right, or the area from 0 to that number would be 0.49, right? Because it's 0.4 and then 0.09.
If it's like 3 decimals, can I get it by the
calculator? Yes, calculator you can get any decimal. Yeah. So I'm not sure if they tell you to only get a calculator in grade 11, that means that get grade 10 exam won't use a calculator. Okay, so you have to probably learn how to use a standard normal table, but that means that they only can give you z up to 2 decimal places. Okay, and if it's more, you have to round to 2 decimals and then you work through the questions. Okay, so let me actually find an example here. I'll show you how to work through that. Areas shown in, yeah, so these ones you can go back and test these ones out. I'll just show you a few examples and then you can go and try the other ones. I'll show you some harder ones, assuming you get the basic concept. So for example, let's visualize this one here. All right, a bit hard to see here. Probability z less than 0.04, and remember this is assuming, okay, or actually no. If it's less than 0.04, then that means that they want, so let's say this is 0.04, right? They want from here to 0, but also continuing to the negative. Okay? Yeah. But remember, when you go past the midline, what's the area on the left-hand side here?
50%. Yeah,
50% or 0.5. So you got to add that to whatever this is. Right? And from 0 to 0.04, use the table. Yeah. Right? So first 0.04, look at the first two, the first decimal place is 0. So you look at 0.0 and then you look at 0.04. So that means that area is 0.0160. So this one is 0.0160, add that to 0.5. That means the answer to this one is 0.5160. Correct up to 4 decimal places, which is pretty good. Because remember that is about 51.6%. Right? Yeah. So pretty good percentage when you're talking about a percentage point. And then how about this one here? Z less than negative 1.6. Okay, all right, let's see. Less than negative 1.6, again, Z means standard normal, so that's 0, minus 1, minus 2, minus 3. So note that normally it will be like very close to minus 3, yeah? I'm just estimating, right? So don't worry too much about the shape, but roughly it's a bell curve. Negative 1.6 is like around here, right? That's negative 1.6. So let's put this on here, and they want the area over here. How do we find this? What do you think?
0.5 minus whatever that is.
Whatever this one is.
Yeah.
Yes, that is correct. And how do we find this one? Let's call that x. How do we find x? And so this one would be 0.5 minus x. Very good. How do we find x?
Let's go to the table.
Yep. Okay.
Because it will be the same for like both sides.
Very good. That's good. I can see why you are an A student. Okay, good. I think you have no problem with methods and specialist. With a bit of my help, I think you'll be fine. But anyway, so the number is 1.6, right? Assuming 1.6 means 1.60. Tell me what the area. What is x? Right, in the one here, yeah? This one. What is x using the table?
1.6. 0.4452.
Yes, that is correct. All right. If you're looking at that number there, that's the correct number. So that will be 0.5 minus x, and now we know x is 0.4452. Can you do that mentally?
Oh, it's like I have to like write from the back. So it'll be at the very back 8, 4, 5, 0.
0.0, yeah. 0.0548. Good, very good. Okay, very good. All right, so yeah, so does it make sense? Yeah, so that's the standard normal. Let me show you. Yeah, that should be fine. Between values, yeah, you can figure this out. I think it's just math. You can get it. Aha, this one, practical applications. So one more formula you need to know, and you will learn that next week. I'm pretty sure.
Do I need to memorize it?
Memorize this formula? Yes. This is the standardization formula. You will learn this again in methods unit 4, year 12. Okay? Standardization formula. It's not too bad to remember. Formula. So the standardization formula is Z of a value is equals to X minus mean over standard deviation. Okay? X minus mean over standard deviation. Okay, yeah, I'll explain each of the parameters. So Z is the corresponding Z value of the X value that we've got, and then mean and sigma is just the mean and standard deviation of the main distribution. So let me use an actual example for you. It will be a bit easier. This one. I'll give you my explanation, and then you hear that again next week from the teacher, so it will, you understand that a little bit better. Because this is actually very important. This is Math Methods Unit 4 content, and when you get to that point, if you already know it, you can get past it a lot faster. IQ tests are standardized to be mean 100, standard deviation of 15. So mean is 100, standard deviation is 15. Okay? And then you have an IQ of 127. Okay, before we get to the question, you can actually map it out using the standard normal, or the normal distribution, not the standard, the normal distribution, right? Because you plus. So 115, 130, 145. So this is an actual number. Okay, this is actual IQ distribution. It is a standard, it is a normal distribution. So 85, 70, and 55. Right, minus 15, minus 15, minus 15. Yep. Then most of the error will be between plus minus 3 standard deviation. It will be something like that. Okay, so as you can see, 68% of the population will have the IQ between 85 and 115. That's like the average point. If you have IQ above 130, what is the percentage of population are you part of? If it's above 130, let's say 132. Right?
Above 130 will
Yeah,
be like,
above 130 would be how much?
1.5 add up, is it 1.5 or 2.15?
Do you remember the three numbers?
68, 95, 97.7.
99.7 is close to 100. Okay, so what number are you looking at here?
99.7 minus 95 and divided by 2.
Yeah. I guess you can work it out that way. 99.7. I guess you can work it that way. Because the other more accurate, because remember, these are all estimated numbers. If you use an estimated and you minus an estimated number, there's more error. So you would just use one estimated number. So I would use 95. So I know from here to here is 95. All right. And then 100 subtract that is 5 divided by 2. So that's 2.5%. Okay. So only use one of them, don't use two of them. Yeah, because they're both estimated numbers. So yeah, so you're in 2.5 if you are above 130. But what if you are exactly, let's say you're exactly, I'll change this one up, not 127, 132. Okay, if you know your IQ is 132, then what's the percentage of people have a higher IQ than you? How do we find that? Well, 132 is here. Okay, so now let's focus on this number here, 132. Note that this distribution, this normal distribution, I can literally just repeat the entire shape. Okay, just repeat the entire shape, but change the number to turn that into the standard normal. And remember, the standard normal
so you can go to the table and then work it out.
Yes, very good. That is correct. And in the standard normal table, this value is the Z value. Right? So note that this is capital Z. This is a smaller case Z. Yeah, it's like a smaller Z and capital Z.
So that's what the formula is for.
That's right. So you convert the number 132 into actually you can find out the so you've got the area here, right? Okay, which is actually no, you want the area. You can convert this one into the Z value, and if you get the Z value, you can find the area, right?
Yeah.
Okay, so then we calculate the Z value that corresponds to 132, which is X. So this is the X value, 132, minus the mean 100 over the standard deviation, which is 15. All right, so that's 32 over 15. 32 over 15, then we get up to, because we only need 2 decimal places. All right, that'll be 2 point something, but let's get up to 2. So that will be 2.13, all right, 2.13333 recurring. So 2.13 to 2 decimal places. So that number is 2.13. Now that means that we can actually go get the area from the table. I think the table I clipped out is not big enough. Okay, so go back to this one here. Let's go to the table. 2.13 is, I think it starts from 0. So 2.1, and then that will be 0.10, 10, 11, 12, 13, that one. Okay, so note that this is the area from 0 to that point. So 0.4834. So 4834. That means that what we just found is the area from here to here is 0.4834. Okay, so how many people have the IQ higher than you if your IQ is 132? Well, it would be this section here, which is just, you know already, 0.5 minus 0.4834. Then yes, you read from the left hand side again, 6, that'll be 661, 0.0. Okay, that means that there's only 1.66% of the people who have higher IQ than you if your IQ is 132. Does that make sense? Because we just found out the area, if it's exactly at this point, then this area to the right hand side of it would be 1.66% roughly to 2 decimal places. Does that make sense? Yeah? What do you think about normal distribution so far?
Pretty good.
Pretty good? Confident? Yeah. Do you think it's an interesting concept?
Yeah.
Interesting, right?
Yeah, it's better than algebra. Algebra is pretty boring.
Algebra is pretty boring. Actually, I like that. I like that mindset that you've got. I like that sentiment that you've got, because the probability is actually what's most relevant to real life. Yeah, and unit 4 math methods, statistics is the most interesting topic in all of math methods. Everything else is like a bit like somewhat interesting, some are kind of like, oh yeah, it's got to work through it. But unit 4 is the most interesting one.
Okay.
It's the hardest one. Year 12, yes, the second half of year 12, that will be the most interesting. When you learn it, you actually can calculate a lot of stuff in real life. And unit 4 in specialist, oh, that one is really difficult, but when you learn it, you're like, oh, I feel smarter. You can actually, for example, do you know how to calculate, let's say if you drop a rock, if you're flying on a helicopter a kilometer above seawater, right? You drop a rock, right? And then that rock hits the water. What do you think is the velocity that it hits the water at? How do we even calculate that?
Oh, that's a specialist?
Yes.
So that's only for like physics?
No. Physics will apply the specialist formula, but specialist, you make the formula. And that's why it's difficult, but you actually can do stuff like that. Okay. In both methods and specialists, there will be a bit of physics. There will be position, velocity, and acceleration. I can tell you that. Okay. We will come to that, but you will learn the math behind that in a lot more details than physics. Physics just applies a bunch of formula, but in math, you derive some of the formulas yourself.
Would that be like vectors and scalar stuff?
Yes. Vector scalars is part of specialists, not methods. But yes, you will use vectors in I think in unit 2 specialist and also unit 4 specialist. You will apply vector calculus and stuff like that.
Is unit 2 like year 12?
No, unit 1 and 2 is year 11. 3 and 4 is year 12.
Oh, well, 1 and 2 is like the last semester of year 11, is it?
Unit 2 is the last semester of year 11. Yes. Yeah.
What about the unit 1?
Unit 1. Okay. Actually, before I get to that, let me double check how much more. Yeah, that one's easy. Yeah, we went through that already. Sub in values. Yeah, we just got that. I think you can go back and try these ones. You can already do. Yeah, that's it. That's all for that you'll be learning at school next week. Right? We still have basically like an hour left, so I can actually teach you more content. Yeah. But anyway, okay, which means you have a bit more time now. Remember when I told you that I want to teach not just math, but like some study techniques and life skills and stuff like that. So this is your first time. I will go through one of those techniques since we do have extra time now that we've done most of the content. Okay. Okay. So there are a few things I want to go through: memory graph, recognition, and recall. But sorry, let me see. What was the last question you asked me? Oh, you did 1, 2, 3, and 4. Okay. So let me use 2 columns to represent. This is year 11 and this is year 12, right? So let's say that's January, or let's say I'll split that into 4 terms. Okay, term 1, term 2, term 3, term 4. Okay. Year 11, unit 1. Definitely in term 1, all of that is unit 1 for both methods and this is the same for methods and specialists. The maths are normally quite similar. Okay, English they will change a little bit, or other subjects will change a little bit. But for math, year 11 will be unit 1, term 1. Maybe I'll write the label here: term 1, term 2, term 3, term 4. And then in in second term, you will learn a bit of unit 1, and then in the last part of it, you might learn a bit from unit 2. Okay, then term 3 will be fully unit 2. Term 4, I think you spend about half of the term learning unit 2, and then you might start to learn unit 3. Now, unit 3 is the start of the content that will go into your ATAR score. Okay. Yeah, unit 3 and 4. And then in year 12, this will be unit 3, but you will have your first assessment, IA1. So this is the first assignment in term 1 in year 12. This will be an assignment. Now, some schools put this assessment here, and some schools, no, actually I think some schools, they actually put the assessment here, IA1 here. I have a feeling your school will put your first assignment, which is an assignment. Okay, this is an assignment at the end of year 11, which is about this time. No, actually not this time. Next year. Yeah, you have 1.5 more years before that happens. Yeah, so that's the assignment. And then unit 3, let's say term 1. Yeah, I think they will finish Unit 3, so they actually cram in quite a bit of Unit 2 here. So only a little bit of that will be Unit 2, most will be Unit 3 in Term 4. So they actually have to start Unit 3 a little bit earlier. Okay, and then Unit 3 will be for Term 1, Year 12, and I think your school will most likely do the second internal assessment, IA. So IA stands for internal assessment. Okay, IA2 is an exam. So it's an exam on Unit 3, and this is 15%. Okay, the assignment is 20% of your entire grade. Okay, and then after that, you will start learning Unit 4 here, and then you will finish Unit 4 in Term 3. Actually, before you end Term 3, you will already finish Unit 4, and then you will do internal assessment 3. This is the exam for Unit 4. Exam for Unit 4, which is also 15%. Okay, and then you spend some time revising stuff, and this is the external exam. Okay, the external.
How long would it be?
Sorry?
How long would the external exam be?
4 hours.
Or just one day? Because I see like many students do it for like the whole term. I'm not sure about it because like our school I do it for one term, so I don't know about it.
Okay. The external exam for all subjects will be the whole term, yes.
Oh.
Yeah, but the actual for each of the subject will be like week 1 could be, I think normally week 1 is English, and then maybe math methods, or week 2 is math methods, and I think specialist is week 4 or 5. So yeah, it's spread out throughout the whole term. I think if you don't have an exam, you just don't go to school. Depend on the school. But you just basically do a revision because Term 4 in Year 12 is all external exam. Yeah, most of them is just external exam because that will be around November, October. Yeah, you might have like a few weeks at the beginning, but then external exam. So your external is the external assessment EA. So that would be 50%. So in total is 100%. Right? Your external is half of your actual math score. Okay? Have you seen this breakdown before? But you're aware of like the 4 units. But have you heard of like all the internal exam and external exam before?
Yeah.
Okay, so yeah. So this is like the more detailed version of it, how many percentage. If you want, just for you, right? If you want, actually I'll show you, this is where you find information. Search QCAA, math methods, for example, a math specialist, right? Okay, search QCAA. QCAA stands for Queensland Curriculum Academic something association, I can't remember. But yeah, so you go to specialist mathematics, general syllabus, yada yada. Now, so I say internal assessment 50%, external assessment 50%. If you go to assessment, you can see exactly how they break that down. So actually, I think they don't tell you the percentage here. I think you have to go into it. Let me see the syllabus. Yeah, so this syllabus is actually it will tell you all of the content that you need to learn. So yeah, yes, here. So this is the syllabus that every single school in Australia, in Queensland, if they teach specialist math, for ATAR, they have to follow the syllabus. Okay, so let's say if you were to click on assessment general information. So you see formative is not counted towards ATAR, it's unit 1 and 2. Unit 3 has the summative, which is counted towards ATAR, internal assessment 1, so the IA1 I drew earlier, right? Which is the assignment. And then unit 3 also has a internal assessment 2, which is an exam, and then unit 4 has an exam, and the external assessment is unit 3 and 4. Now, even though the summative one doesn't have unit 1 and 2, you cannot slack off on these ones because many of the content from unit 1 and 2 will be used for 3 and 4. Okay, it's just that in unit 1 and 2 you will learn a lot more. So this is what you should visualize. If you have unit 1, right, and then unit 2, half of that content will be used in unit 3. And half of the content in unit 3 will be used in unit 4. That's why, if you're aiming at 9 really high ATAR, you do aim to master everything. Okay, but you don't need to remember everything from unit 1 and 2 for the external exam now. Okay, I'll give you what you need to remember. There's no perfect answer, but I'll give you the best, like, I guess, guide for that. Now, this is the let me go back to the one here. In this document, they also tell you what are the topics that you need to do for specialists. So unit 1, combinatorics, vectors and proof. Okay. If you go to the actual topics, there are 3 topics here. You can tell what will be underneath it. So I'll just show you how to read one unit because unit 1, 2, 3, 4, they're all here. So I'll show you how to read one of them, and then you can just like go back and figure out the rest of it. So if we were to click on this one here, what you want to pay attention to is a few things. First, you skim through it, right? So topic 1 is there, topic 2 is there, topic 3 is there, and that's it. Okay. What you want to pay attention to is first how long the table is. The longer, the more content, right? If you want an actual value of how long it is, look at the hours. Okay, so that's 15 hours in total. Okay, so let's say if we were to write 15 hours of, so this is estimated teaching time. They're supposed to spend 15 hours for these topics at school. Okay, 15 hours, if we count the vectors one, is 6 plus 11, 17, 17 hours. So you can guess that it's about the same amount of content. And then you look at the introduction to proof, it will be 5, 4, 9, 17, 23. This one, a little bit longer. The number of hours corresponds to how much content there is. It also corresponds to how many questions will there be in the exam. Okay, so if you add them all up, let's say 15, 17, 23, it will be 40, 55, right? In total it's 55. So this is 15 out of 55, which is roughly about, you can expect about 27% of the exam will be on this. Okay, and similarly, 17 out of 55 would be about 31%, rounded to whole number, 31%. And then that will be 42% here. So this one will be 42% on the exam. So based on this, you can see, probably you want to put more effort into topic 3, for example, because that covers more. But again, if you're aiming for 99 ATAR, you're aiming at like a 90%, 90+% for the exam, right? Are you?
Yeah.
90+%? Yeah, then you got to master everything. Okay? When you're doing the revision, right, I normally don't like show students this one, but if you understand this, it will give you some idea on what you need to focus on, because sometimes the teacher at school, you have me, so it should be okay. I will go through the key points for you, but sometimes the teacher at school, they may delve on certain topics. I'm not sure how good the teacher is, so I'm just going to make the assumption that they're average. Okay, the average teacher at school, because they need to teach a lot of content, sometimes they will skip over some parts just to get like some other parts down. Put it that way. Yeah. But the teachers who are teaching you may not be the one to design the exam. The one who designs the exam, if you get a teacher who designs the exam, you're lucky, because then they will teach you something close to what they will have for the exam, right? But if not, then you have to somewhat rely on this document here. All right. Let's see. Use to quantify. So say before the exam, you're going to revise. Look back at this, and you'll be like, okay, do I know how to use the quantifier for all? And they exist. If you don't know that, probably go back and revise. Okay. Or let's say if we're looking at vectors, like, do you know what a magnitude and direction of vector is? If not, probably go back and revise it. So this document will also help guide you on like what you need to revise. Okay, closer to the exam. Because sometimes teachers, I'm not relying on the teacher too much, because the school program varies. But some schools, they give out a very good list of like, these are the topics, checklist, 20 dot points, perfect.
Yeah.
Does the school do that?
Yeah, but only for last term. They didn't give us like previously, but only for last term.
That means they might do it from now on, which is good. If you get that, lucky. Use that, revise. If not, based on this. Even better, based on that topic and this list. Alright? Yeah. If you know every single thing in here, like if you can tick off like, I know this, I know that. If you can tick off everything, basically good. Right? Basically, if you've got most of the concept, and then you can start like focusing on working on the question and stuff like that.
Yeah.
So that's how you use this official document to your advantage, right? And right now you only care about Unit 1, which is what you will start next year, term 1. Okay? All right. So yeah, so that is about the specialist and methods, same thing. The program for next year, that's what you most likely be doing at school.
Yeah.
So, okay. Now I want to go through one thing. Recognition and recall. What do you think is the difference between recognition and recall, James?
I thought they were just like both revise.
Yeah. It's a good, it's a good initial step. Yes, they are both about revision. Now, if I were to ask you, do you recognize? Okay. So the first step is to recognize. And then the second step is to recall. Okay. So I'll put that here first. Now, if I were to tell you, do you recognize the McDonald's sign on the road?
Yeah.
Yeah, right? Easy, right? Everyone can do that. Recall, can you draw that sign?
Probably not accurate.
Probably not accurate, right? You probably get like a M, or some student good enough will get like that, whatever. But if you actually look at an actual McDonald's sign, okay? If you actually look at a McDonald's sign and you really pay attention to it, you see that the bottom of the M at the middle is actually higher than the M here. And then the arch is like skinnier on the top and then fatter at the bottom. And the other part of the M, like the top line, stops here, but the bottom line stops here. And it's a flat line. Okay? So you see, if you actually pay close attention to the actual McDonald's sign, there's more than just an M.
Yeah.
Right? And in math, this idea is the same. Normally, the student, most students make the mistake of thinking that, I understand the question. Yeah, good. Now, you're only recognizing the answer. So when I was explaining like all of these concepts earlier, what you have done so far is recognizing the answer. All right? So I show you the answer that, yeah, makes sense. That's the answer.
Yeah.
The next part though is the real deal, recall. Can you do the entire question yourself without any help? That's perfect recall. You see? You see the difference between like seeing an answer and be like, oh yeah, it makes sense, versus like actually being able to reproduce the answer. Because in the exam, they don't ask you to look at an answer and be like, oh, is that correct or wrong? No, you write the answer yourself. So that's a mistake that most students make. I'm sure you don't actually make that same mistake. You do practice, but this is to I just want to show you that the difference between recognition and recall.
Yeah.
Alright, so you understand that. Don't delude yourself when you hear the answer from the teacher. Like, that's just recognizing. I gotta practice recalling it. An example of that is, let's say if you're I'll use this one here. So let's just say if your teacher is doing this practical application, right? Let's just say your teacher is going through this at school. If you don't have me, you will have to most likely follow it to understand. And then the teacher will give you a chance later, and we'll get to like say question 1 and 2 here. So I can see that your school is actually pretty good because they give you the recall opportunity like straight away. They give you the questions straight away. And forcing you guys to actually go through the questions. I don't know if they will have the time to go through the question or just be like, you guys go back and do homework. But it's very important to do these questions again.
Yeah.
Or to do these questions, not again, to do these questions. And then check your answers as well. Okay, to make sure you get it right. So do you normally check your answer?
Huh?
Do you normally check your answer?
Yeah.
Yeah? Okay, good. Keep doing that. Because what another mistake students make is to finish the question and be like, yeah, I'm done with the question, put it aside, done with my homework. Nah, you check your answer. So if you do get any document from me, normally I give you the answer at the back. Okay, so sometimes I will give you a revision sheet and stuff like that, or like sheet to practice on. There will always be answer at the back, and my trust is that I trust that you will not just copy and paste the answer. For most questions, especially, you can't copy and paste the answer. Right? Most questions you actually have to work through it. So it doesn't even work anyway. So you always want to check your answer at the end to see if you actually get it right or not. And then if you don't get it right, try to figure it out. If not, ask me on this call. Okay?
Yeah.
Don't spend too long on the question that you're stuck with. Okay? Just ask me and then I will provide the answer for you. Okay. Now at school though, with my help, when you get to this point, how many students are there in your class?
Approximately like 25.
Okay. Can you do math without your teacher, like, I guess, being like, James, what are you doing? Listen to the teacher got that?
Yeah, I can do that.
Yeah. So my advice for you is when you get to this kind of point, right? If you think you can do it, you do it before the teacher. Do you do that? Sometimes?
Not for something I haven't learned.
Oh yeah, of course. If you haven't learned it, then yeah, you normally have to listen to it, right? But okay, brings me to the next point. Normally you don't have to do this, but yeah, okay, yeah. I'll go to the next point first, and I'll tell you why. So this is, I call that the memory graph, or some people call that the forgetting graph, but I call it the memory graph. So first, recognition and recall, and second is the memory graph. Okay. What is your, let's say, do you remember what your address is back in China?
I can say in Chinese, but not English.
Yeah, but you remember that, right?
Yeah, I remember.
Yeah? You see, you can remember something that, like it's a long time ago. Like, when was the last time someone asked you your address in China? Probably like never, right? Yeah. But you still remember the moment I said it, it's there in your mind. Why is that the case? Well, the difference is between short-term and long-term memory. Short-term memory is short, right? You need to push stuff into long-term memory. But how? How do you actually do that? So I'll simplify that by, this is using a graph. This is your understanding. Right? Let's say that's understanding.
I thought you just do like many questions and then you'll remember. Because that's what we do in China.
Yes, you do many questions, but there is an important factor, which is time. Okay, the time factor is the one that most people actually want. Want to tell you, like, oh yeah, do more. But let me show you something. I'll show you two scenarios. Sure, you do a lot of questions. Let's say you do a lot of questions at the beginning, right? Assuming you do a lot, let's say your understanding goes up like that. Okay, over time, that understanding decreases. You can't help it. You will slowly forget, right? So there are things that you learn, if you don't repeat it, you'll forget. So let's say you learn a lot at the beginning and then you do nothing about it. That's the rate of forget. And then at some point in time, you hit zero. Well, of course, it's not that simple. But it will be more like this, right? You don't really forget it 100%. But I'm just going to simplify that by using a straight line. Okay? Because sometimes you do forget most of it, and it's very hard to recall it. So I'll consider that zero. Okay? So this is zero understanding, and this is the start. Now let's say you do a lot of work and then you don't do anything that hits zero. All right? So this is not really a scenario that you want. So what you actually want is at some point. So let's just say instead of drawing the same line, I would draw two lines, right? A shorter one and then another shorter one. Instead of doing these two at the same time, I space it out. Yeah. So instead of doing like say 100 questions at once, I do 50 and I leave 50 for later, or maybe 200 too much. 10. Instead of doing 10 questions, I do 5 now and want to do 5 later. See what happens. So that line represents 5 questions each, right? About the same, yeah? 5 questions each, assuming you gain the same knowledge. So after you do 5 questions, go away, right? And then let's say you go to sleep or whatever, you start forgetting. Naturally, you start forgetting. And then let's say this line will be different for everyone, but let's just say it's like that. And then at this point, it could be a couple hours later, it could be a couple days, but normally no longer than like a week, less than a week. Okay, and again, as I said, it's different for everyone. Then you do 5 questions, and it goes up. Sure, it doesn't go as high as that point, right? It's still a bit lower because you forgot something already. You struggle a little bit. But in fact, if you let your brain forget a little bit and you do more questions later, your brain already had time to organize the information. So from time to here, the forgetting is actually, okay, put it this way, when you're forgetting something, it's not because your brain is stupid. It's because your brain is organizing the information. And your brain is thinking, okay, this one, not useful, throw away. This one, not useful. This one, oh, these two related. Okay, remember those ones. Okay, so your brain is actually organizing information when it is sleeping. Right, sleeping is an example, but whenever it's like active in a certain way. But we're going to the biology now. So that's why you actually gain a little bit more knowledge. Right, that's one thing. The second thing is not what happens to the rate of forgetting. Right, see the gradient of this one and this one is not the same. It takes longer for you to forget. Okay, again, this is just a representation. Don't quote me for this. This is not a scientific graph. But it takes longer for you to forget. And let's say at this point, you do 5 more questions here. Right? Then the forget curve might actually look like that now. So around exam time, you might still remember a little bit of it. And then you just need to do 5 questions. And then your understanding goes up to the previous point or even more. So that's what I'm trying to say here, James, is that doing more questions, good, but space them out. Okay? The time between the session is as important as how many questions you're doing. Okay? And you see, let's just say initially you start actually forgetting very quickly, right? And then you go up like that, and then you start going, down to, let's say, that point there. Okay, so let's say if I would adjust the graph like that, so this is time 0, right? This could be like 1 day later. And then you see how actually you don't need to revise every single day on the same topic. You can space it out. This one could be, I don't know, 5 days later or 7 days or 3 days. Again, it's up to you. Okay, it depends on the concept. Some concept it's harder, so it takes longer for you. It will be more of those little jaggedy lines to get up to the high point. And some concept you might just go zoom and you're like, oh, I kind of get it. So it's already at a slow decrease rate from the beginning. So it depends. But the idea is that if you space out, you don't actually need to revise the same concept every day. You space it out. But note that you will feel a bit of like a drawback, because you're like, last time you're like, oh yeah, my understanding is here, right? Then if you leave it, your understanding goes down, right? Then you're like, oh, I forgot this already. Oh, I'm so stupid. No, it's a natural forgetting mechanism of the brain to organize information. You just gotta tell yourself, yeah, that's fine. I forgot a few things, no problem. I'll learn it again, and this time I will gain more knowledge. You gain more than last time. Okay, so that's how I explain, like, study smarter, not harder. Someone can do the same 15 questions and not be as good as someone who do exact same 15 questions but space it out in like some sort of interval. Right? So that's how some people, they can just like study very little. Right? You may know some people, might be you, but you may study only like a couple of weeks, and you still have time for sport, have time for co-curricular activities, and then sometimes there's someone who's just like sitting down and do like hundreds of questions per day, and they get the same result. And that is because of the nature of the brain here, where you start forgetting, so you need to be very strategic with when you do the questions. And that's why when you feel that, for example, today we learn about normal distribution, right? Say tomorrow. Today is Tuesday. Okay, say tomorrow. It might be the first day that you're like, I kind of forgot a few things. Okay, let's probably just go back and revisit the normal distribution. Okay, and then that's when it bumps up your understanding. Right, and then maybe before school next week, before class, actually I'll get to that point in a sec. Before class, you revisit that again. Okay, you revisit that again, and then you bump your understanding up. So by the time you hit class, your understanding is at a high level, which means you can even like get more understanding. But of course, there is a diminishing return factor. You know what diminishing return is? I'll get to that in a second. So there's a diminishing return factor, which means you may not gain as much. After a certain point, you may only gain a little bit, because maybe there's a cap on the knowledge.
So that's the limit? So that's like the limit, the highest point you can get? Sort
of. There is virtually no highest point. Okay? There is actually no limit. The sky is the limit. People say that, right? The sky is the limit. Because it is true. There is no limit to the level of understanding. Put it this way. 1 + 1 = 2, easy, right? But if you understand decimals, then you see, oh, this is 1.0 plus 1.0 equals 2.0. So on the decimal scale, it works in the same way. Or in a fraction, you can also see, oh, well, let's say if I do 6 over 6 plus 1 over, let's say 4 over 4, the answer is still the same. 2 you can write as 2, or you can go fancy, right? 12 over 6. Okay? Same concept. But if you have more knowledge, you can see it in different angles. Okay? So even something as simple as 1 plus 1 equals to 2, you can still see that in many, many different angles. Right? Or something like, let's say, another one would be, let's say 2 plus 2 equals 4. You can see that as that, or you can see, oh, hang on, I can take out a common factor 2. So inside would be 1 plus 1, and then that would be 2 times 2, which is 4. Oh, you just turn an addition into a multiplication.
Yeah.
Right? So this is what I'm trying to say by there's almost no limit to the level of knowledge. So that should probably give you a bit of a sense of humility that there's no way you can know everything in the world. There will always be someone out there who's smarter than you. I'm definitely not the smartest. I'm not the best person in math. I'm just good enough that I can help some of my students get better in math. Okay, and that's okay. That's okay. You don't need to be the best. Elon Musk, probably not the best. Okay, what's his name? The Chinese Jack Ma, right? Is probably also not the best business person either, right? But they are good enough to get to where they are, and you also don't need to be the best. You just need to be good enough. Okay, but anyway, so that's the idea that there is no limit, there's no maximum you can learn. But that brings me to the next point. So note that today I'm going through a lot of these little concepts that's not math related, because I'm giving you that little bit here at the beginning. Okay, I will revisit some of these concepts later, but it won't be like a long ass explanation anymore. It will just be like, oh, do you remember the recognition and recall? Right? Or do you remember memory graph? Right? Later. But the first lesson, normally I want to go through as many of these study techniques as possible, because the sooner you start applying these things, the sooner you can find yourself, oh, I actually get so many things and I still have so much time left. Alright? This memory graph is one of the most important teaching technique that applies not only to math but to other subjects as well. You're doing biology, the point where you learn a new concept, alright, and you start forgetting it, it's very applicable to biology. Same with recognition and recall. When you read a paragraph, like what is the definition of a cell wall? A cell wall is a membrane around a cell that contain the cell organelles, for example, whatever. Let's say that definition. When you see it in the textbook, you're like, oh yeah, that makes sense. That's recognition. What is recall? What do you think recall is?
You can actually memorize and write it out by yourself.
Yes, write down by itself. And that's where flashcards, like the flashcards.
Oh yeah.
That's where it comes in handy. Do you use flashcards to study?
No.
You should. Okay? You should. Flashcards, you put, because you're doing 3 sciences. Chemistry, okay, physics not so much, it's calculation. Chemistry, biology, there will be concepts that you have to memorize, right? Like definitions, concepts, whatever. You put the definition down in the front. So for example, cell wall, or let's say in chemistry, atomic number, right? Or like the proton number. Okay? You put down proton number, you write explanations at the back, you have a stack of those, right? And then when you want to practice the recall, remember the part where you need to actually do the recall. So when I said that, like, you increase your knowledge, you have to recall. Yeah, when you're just recognizing, you're reading, oh, what is a cell wall, blah, 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 oh yeah, that makes sense. No, that did not increase your knowledge. Okay, you have to practice recalling. And the point where you can look at something and you recall it perfectly, that's when you know, oh yeah, I have got like a pretty high level of understanding somewhere up there. Okay, so imagine you have a stack of flashcards for biology. Oh, this is so powerful. I use this a lot in the past, but I don't see many students use it. I think it's such a waste of time. You have a stack of flashcards. There are more techniques I'll tell you later, but let's say you have 10 of them, right? Today, you try to study 10. You pick up 10 and remember the memory graph, so you're doing it, let's say, the second time. Try to memorize it. You're like, oh, I don't know what it is. Try to write down, oh, I forgot half of it. Read it. Oh, it makes sense. And then rewrite it from scratch until you can read that and you can write the definition out fully, match exactly or like close enough to the definition. Good, put that aside. Do that 10 more times, you got a stack of 10 cards. And just tell yourself, those 10 cards, I did it today. You probably need to schedule in the time, let's say, depending on how comfortable you are with it. If you are like pretty good with it, then maybe you can schedule a time 5 days later. If you're like, I think I'm not very good with it, do it tomorrow. Okay? Yeah. Tomorrow, you pick up the same stacks of 10 cards and you practice that again. So you look at the definition. Oh, cell wall is the membrane, blah, blah, blah. So you try to write it down as much as you can. The idea is not just to say it, you write it out. Because in the exam, you write it, right? So you write out. If you're stuck, you're like, oh, okay, let's look at the answer. And then you check, see how close it is. Write out, finish that answer, right? And then make sure you memorize that. Chuck that away, put that aside, cell wall, write definition again. Until you can write the full definition correctly, you're not done with that study session. But once you're done, if you can write it correctly, yep, all good, put that aside. Right? Do that 10 more times for that slide. And then you see that when you find out, you see that actually you can memorize some of them quite well. And so those ones, you schedule them for, let's say, 7 days later, a week later to revise. Yeah. You see that one step of revising that concept takes like what, a minute, maybe 2, right? Harder concepts, maybe if it's like a whole process in biology, it may take you like 5-10 minutes to fully memorize all of the steps, right? But as you keep on doing it, it becomes second nature. Like, why do you think I can say all these things, so quickly? Because I've done that so many times. I've done so many of these little things that my rate of forgetting curve, what I'm saying, is like basically 0, right? So good teachers, they know their stuff because they've taught it so many times. They have recorded so many times already, right? And it must be spaced out. Yeah, like if you do all of this one time, and you're like, I'm good, put them aside, you forget about it in like a week or so. Yeah. So do you use Google Calendar or some sort of calendar to schedule out your study or like set up events? You should. I will introduce you to, do you read books?
Not really.
Okay, so should. Okay. I'll give you one title. Just read this one first. It's called Getting Things Done. This book is about time management, okay, and task management. And as a student, you have a lot of tasks. You have to study 6 subjects and try to get high marks in 6 subjects. That's a lot. Like a full-time person, most full-time people, they only have like, 3-4 set of tasks to do. So a student's life, actually not easy. A student life is one of the harder. Especially a high-achieving student's life is very hectic. Okay? It's very hectic. So if you are trying to achieve good results, it's going to be very hectic. So you need to be efficient. So I'll introduce the main concept that's mentioned in this book. So the idea is that if you want to do a lot of things, like what I said earlier, right? This thing with like the flashcard. Let's say if you have a few tasks. So based on what we said at the moment, let's say you have a task called create flash cards, right? For let's just say chapter 1A biology, okay? Or you may have another task called do 5 questions from chapter 1B math methods. So you see how these actually turn into tasks, and then do, let's say, 5 questions from chapter 2A math specialist, and we can keep going, right? Or one of them could be revise flashcards, FC flashcards for biology cells, chapter 1. You see, to organize your study and make the most out of that memory graph there, you need to create tasks and you need to go to schedule them. Right? What I said earlier, revisit this 2 days later, and then 2 days later you've done this, or revisit this maybe 2 weeks later. Right? So you need a system to organize these things. All right? And that system you need, so there are 2 steps. Step 1, you need an inbox. You can start with a physical system first. You don't need to use an app. I use an app because I have like 40 tasks to do every day. I have to prioritize them. We'll get to prioritize them in a sec. But you need an inbox. It's like your mail inbox where everything goes in there. Okay? So imagine like literally like a box. Let's say that box there, right? That box there, you would have, or it could be like your computer screen. So let's just say you have these flashcards. Right, these sticky notes. You can write down, create flashcard chapter 1A. Put it out, stick it, I don't know, let's say that's your work, right? You put it here. Even better, if it's your calendar for the next 7 days, right? You can stick that onto each of the days. So let's say that is like Monday, Tuesday, Wednesday. So you say, oh, I want to do that. Let's say today is Tuesday, and let's say it will be like Monday, Tuesday, Wednesday, and you're like, okay, Wednesday, I want to do that task here, and I want to do this task here. Right? So you can schedule these tasks onto the calendar. That's why I'm asking you, if you have like an app, then it will be easier because you can put that into the app. There's one app that I use, I think it's from a Chinese developer, it's a really good app, it's called TickTick. Okay, so I'll show you an example of so yeah, this is the app, it's called TickTick. Okay, and in it, you can create different lists. I won't go into too much details, but and then today, so whatever I schedule for today, it will be all these tasks here. So I will try to get all of these done today, but normally I'm overwhelmed with too many tasks. So anything that is in red, like conduct lessons for you, James, and then the previous lesson, yada yada, anything in red, I will get it done today. And yellow is like lower priority. I can push it back a little bit. Blue is like, oh, it's nice to do, but not time. If I have no time, no problem. Okay, so that's an example of how I organize all of my tasks there. Right? And then there's an inbox where if there's anything that I can just remember, like, oh, for example, when after Saturday, I put in a task for myself, prepare a welcome pack for James. So I put that into the inbox. So I just pause and then go create, I just type like create welcome pack for James and then add that in here. So the idea of the inbox, okay, and actually that's just where you chuck all of the tasks that is not sorted. Okay, so this is for unsorted tasks, unsorted. Right? Anything that you have no time, you chuck it in there. The idea is when you put when you put all your tasks into a certain inbox, either in the app or like a physical box, you know that it's there. You won't forget about it. Right? You won't forget to revisit these flashcards. Like, you will not forget about it. It's in there. Right? And then step 2 is you need to once a day or once a week, or normally once a day, for example, right? Once a day, you need to organize inbox. Organize the inbox by either, if you use that app that I use, I put into a certain list and then I schedule when do I want to do the task. And I also put a priority, like how important is it? Like, do I have to do it or is it like a nice to do? So the book Getting Things Done, reading this book is also like a nice to do task, right? Or like a medium, I'll say that a medium priority. Because if you do it, it's very good, right? But if you don't do it, the school result will not be directly affected by it, right? But before the exam, if you don't revise the questions, it will affect your exam results. So those are a high priority, for example, okay? And revising like the flashcard and stuff like that can be considered like medium priority. Where if you do it, it's really good. If you don't do it, it doesn't directly affect your score, but it will affect your score. It will make studying a bit harder later. Because in the graph, if you don't study at this point, if you study at a lower point, you may not get back as much knowledge. Okay, so you need to start monitoring and reflecting on how much do I think I remember the concept from yesterday, like the normal distribution that I went through with code yesterday. How much do I know? Sometimes you may even go back. I know it's a bit late, but you may even go back and read this before sleep, because when you finish with me, it's like 8 p.m. for today, right? 8:10 for today, right? You go home, and by the time you go to sleep, let's say 10, 11, or 1, 2 a.m. I don't know what time you sleep. Right? Let's say assuming it's like 11 p.m. It's already 2 hours or 3 hours elapsed between there. Your brain will start to drop down, start organizing information, your understanding drops down a little bit already. Alright, so if you revisit before your sleep, even if you don't even need to redo the question. If you can redo the question, perfect. Okay? I rarely see a student do that, but if you can, that's perfect. If you're really lazy, you're like, I just want to go to sleep, but I still want to get some knowledge from it, take out the notes. I'll send you the notes after. Go to Discord, tap on the note, skim through it. Oh, yeah, standardization formula. Yep, okay, I remember vaguely that one. Oh, yeah, 68, 95, 99.7. So you're doing recognition only, right? But even that is better than nothing. So I mentioned earlier that in this graph here, when you do like the recognition, you may not gain as much, but you still gain something. So imagine if you are like at that point there, right, before your sleep, you do a bit of recognition, it does bring it up, and then it does drop the forgetting curve very slightly. So when you revisit it tomorrow, it may at actually a higher point than it would have been if you didn't do the revision. So you see, the first few revisions has to be spaced quite close. That's why when you learn something at school, you revisit it the night of the day, right? The exact same day, nighttime, you have to revisit it, okay? That's the best time.
Yeah.
And then you can leave it for a couple of days, normally. And if you learn that, try to revise that, like a couple of days later, it's okay. Okay? But the very first time is very important. The very first time you learn something, you start forgetting very quickly. Okay, so you need to revise as soon as possible and as rapidly as possible until you feel comfortable with the concept. Then you can just let it go without revising for a little bit. But remember, you still need to revise. Like this line will still reach zero. Right? It does reach zero. It will continue to go down. So you still need to schedule a time to go up. You see how to efficiently do it, you actually need to manage the task very well. And human brain is limited. The short-term memory is limited. Right? Even long-term memory is good, but short-term memory is limited. So you can't actually manage like 6 subjects, 6 sets of tasks. Because like in biology, you might have chapter 1, 2, 3, 4, 5. There's no way you can keep track of when was the last time I studied chapter 2. Or wait, was it 2 weeks ago? Was it 3 weeks ago? When should I do it now? Have a task system. Okay? Have a task system. Getting things done will introduce you to the core concepts behind task management and time management. That book, I can't recommend that one enough. I read that like 3 times already. And the current system that I have is derived based on what the book said. Whatever these books say, right, it's not going to be 100% applicable to you. So you have to adapt that to your own circumstances. For me, I like software, so I have managed everything in the software. But for you, you may like a physical system. I know some students, they keep a notebook where they schedule all the tasks out, like a calendar book, like those. And they put the task into the calendar book because they don't like digital system. That's fine. Either way, whatever works for you. But the main concept in the book, Getting Things Done, will help you understand how to manage your tasks as best as you can. And some students, I will not introduce this to many students because they are lazy. Okay, you know how students can be quite lazy. And even if I tell them to, organize your tasks, but they have none of these tasks, they won't even think about doing this. So there's nothing to organize. I'm free, nothing. Let's go hang out tomorrow. But I know that I'm assuming. Okay, I don't know, but I'm assuming that you're one of those students who want to do very well, not just now, but also in university. Do you?
Yeah.
Okay, and if you want to study medicine, that graph, you're learning like 100 concepts in medicine. If you want to be a good doctor, you need to learn like 1,000,000 concepts. To be like, the more you know, the better it is, right?
Yeah.
And normally we're surprised that, how come this doctor they know so much? Like they don't even have a textbook to reference. Well, they've got the knowledge in the long-term memory. Okay, and that graph is how you push something into long-term memory. Rapid learning, and then until you master enough, you leave it. But you still need to revisit it from time to time. I have a friend who has a PhD, and he is studying, he's doing medical research on mice. So using mice to test drugs and stuff like that. And he learned how to, not a very nasty, you may say, animal cruelty, but he has to kill the mice. They call it culling, right? C-U-L-L, cull the mice. It's like he's done an experiment and the mouse is like sort of dying. It's a humane way to let it go, right? So cull the mouse. So he has to learn to. It's a funny story. But he has to learn to. Let's say that's a mouse, right? It has a tail, right? You need to pull the tail in a certain angle. So pull it and pull at a certain angle so that it snaps the neck, so the mouse dies straight away. So that's actually a more humane way of doing it, rather than like if you struggle, then the mouse is like in a lot of pain, right? It's not very nice. So there's a certain technique has to go like, and then the mouse dies straight away, and that's it. It's a humane way to kill the mice. That technique, he needs to, even though he doesn't actually use it, because you can choose to either do that or you can gas it to death. As a medical researcher, he has to relearn that technique, like officially recertificate every 3 years. So you see, even like professionals, that curve applies for professionals. You learn it once, they don't assume you know it forever. Nah, retraining every 3 years, right? Because that's if you get something in long-term memory, every 3 years it gets to the critical threshold, like below the point where they think that after 3 years you probably don't do it as well. Should learn that again. Okay, so that's another story behind the manifestation of this curve here. Okay. Tell me what you think so far.
Pretty good. Learned like a lot of stuff about learning, like actual learning, not just like the lessons.
Not just the lessons, right? Actual learning. Okay, good. Now give me see, I'm doing the recall now.
Yeah.
Give me a summary of what you have learned so far. That's it. Just give me a verbal summary. It doesn't need to be accurate, right? Just give me a verbal summary.
What we learned today.
Yeah.
The normal distribution. Standard normal distribution.
Very good.
Standard deviation, and how to like read the graph.
Yep.
And the three numbers, the 68, 55, and 95 and 99.7.
Very good.
And then what is it, like same on the both sides for the graph.
Yep.
And all the learning techniques, so like how to push the short-term memories into the long-term memories.
Okay.
And then use flashcards. Read the book. I can't remember, like Getting Things Done, is it?
Yes, perfect. It is called Getting Things Done. Yes.
And then use flashcard and use like a software to schedule your day to make it like more organized.
Yes, good. That's it. Yeah. So you see, you actually have very good memory. Most students, if they don't focus, they won't be able to remember most of that. Let me put down the software for you. So the software term name is called Tick. Alright, so that's the name of the software that I'm using. I highly recommend that one. But you can also use Google Tasks and all that stuff. But I personally recommend this one. So yeah, good. Yeah. So that's what I meant by I want to pass on all of these knowledge that I know. Most of these things that I'm telling you right now, I actually applied them back when I was a student, but I didn't know. I did it intuitively, or I guess I was lucky. So that memory graph there, when I felt like I need to revise, I revised, right? And it may be, it may not be for the exam. I'm just like, I want to know what that concept is. I forgot about it already. Okay, let's get the biology. I did biology and chemistry. I did International Baccalaureate, IB. So it's 6 subjects, but I didn't do 3 sciences. I did Spanish. So English and Spanish. English, Spanish, high-level math, high-level biology, and high-level chemistry. And the last one I did was economics. Yeah, so I didn't do 3 sciences. I didn't do physics, but I can teach physics, no problem. But anyway, so for biology and chemistry, for biology, if I was learning something, I feel like I kind of forgot already. I would actually go to the textbook and read it. But back then, I made the mistake of just reading it. And sometimes only close to the exam is when I would be trying to recall the answer. But now, if I look, now I'm looking back. If I practice recalling earlier, it will be so much easier to revise for the exam. Like if you get most of the concepts at school, it will feel a bit weird. It's like you learn chapter 1A today, and tomorrow you're learning 1B. But you're revising for 1A. Your friend might be like, James, what are you doing? We did that yesterday. Like, why are you learning it today? Well, they don't understand that it's this initial part of the memory graph. Okay, to push into long-term memory. If you learn that enough, you may not even need to revise the night before the exam. I'm serious. I got to sometimes I was lucky. I did the exact path of the memory graph for some topics, and I find myself I don't need to revise before the exam. Like if you ask me, I know exactly what the structure of the cells is and what the function of the organelles is because I revised them so many times in the past. Where that normally happens for the topics that I'm interested in back as a student. Okay, but if you apply that for every single subject, life will be a lot easier. That's how you study smarter. One last thing I want to pass on today is the idea of diminishing return. Alright, actually before I get to this point, just a random question, but where do you think I get all this knowledge from? Why? Give me a guess. Any guess is fine.
Parents?
The
parents?
Incorrect. I'll get to the parents in a second, but not. 2 more guesses. Give me 2 more guesses. Where do you think I get all these knowledge from?
The book or yourself? Book or yourself?
Book or yourself?
Yeah.
Right? Your second answer is correct. Books. But to extend on that, books and so basically learning resources. Right? Learning resources these days, I'm not limiting it to books because you can learn from YouTube. Right? There's so many educational videos like TED videos on YouTube. Veritasium, you know that channel, Veritasium. No, that's fine. There's many YouTube channels that are educational, or like Kurt Snigger or something, I can't remember. But I follow a few of them, and you can learn so many new things on YouTube. All these things about learning theory and stuff like that actually came from TED videos that I watched like ages ago. Okay, and then I watched many of them that share the same idea, and then I slowly form my own theory around it. So yes, books are learning resources, and then I have to internalize it to my own knowledge and become something that I believe in. Okay, so that's why reading books. When you do medicine, you have to read lots and lots of books. You can't learn everything at school. You will have to read lots and lots of stuff. So be prepared for that life. Yeah, books are actually quite interesting. Like if you know, when you get to the habit of reading a book, there is a book called How to Read a Book. It's a book to how to read a book. Okay, you can look that up. But that book actually teaches you how to make the most out of the books, not just start to end. So in short, I will give you a snippet of it. You read the titles first. Right, chapter 1, oh, this is about this, okay, interesting. Chapter 2, oh, it's about this, okay, interesting. You go through the table of content to get a general idea, and then you slowly dive into, but you don't even need to read from start to end. If you find, oh, I actually want to read this chapter 5 first, go to read chapter 5 first. Make reading book like a fun thing. You can read it in however you want. There's no right way of doing it. There's just some recommended way, but there are, there are many ways of doing it, right? And there are more efficient ways to do it too. So how to read a book? Interesting, right? Anyway, last thing, diminishing return. So this is the idea so many things. Okay, I'll pass on the other ones later. But let's say diminishing return. I'll just give you a quick explanation of this. Give me your favorite food.
Rice.
Rice, right? Rice with what dish?
Just fried rice.
Fried rice. Okay, let's say fried rice. I give you a bowl of fried rice when you're hungry. Yeah. You'll be very happy. Yeah. I'll give you another bowl of fried rice. You'll probably still be quite happy, but if I give you the third one, do you think you like it as much? Not quite, because you're kind of getting full. Yeah. That's the concept of diminishing return, right? The more you get of something, the return, or return here means return of the value, right? So the return you get from eating a bowl of fried rice is happiness, or you feel happy, you feel reducing your hunger. So that's the return from eating the fried rice. But if you keep on doing the same thing, the return diminishes, reducing, right? The return will reduce over time. You don't get the same out of it anymore. Another example is this. In the academic world, let's say you read a certain paragraph about, let's say atoms, right? About atoms for chemistry. Yeah. You read the textbook paragraph, and then you think you understand some part of it, and you read it again, you understand a little bit more, but at some point, you don't get much out of it anymore. In order to know more about the atom, you need to get to a new learning resource. Be it do exercises, or online videos, or a different textbook, right? It's a different resource, because the return you get from the same thing will reduce over time, will diminish over time, right? So there's no point trying to read one thing like 10 times, because you don't get much out of it after like 3 or 4 times, right? You actually need to read more different types of resources. And that's why someone who likes to read widely is actually better than someone trying to read like the same book 10 times. You don't get much out of it. Diminishing return. Okay? So it applies in many, many areas of life as well, but just remember these ideas. Okay? So I'll wrap up for today, but basically remember recognition and recall. Yeah. Recognition is the start, but you have to practice recall. The memory graph, you gotta space it out and rapidly review it so that you can push it slowly into long-term memory and forget slower. And 3, please read a book, Getting Things Done. That's the number 1 I recommend if you want to be efficient as a student in year 11 and 12. That book is key. The software is optional, right? You can use a physical system. The book talked about physical system first, and then they also recommend a few software, but I just recommend you go straight to TickTick. And the last one is just remember diminishing return. So at some point, you may feel you may not get as much out of something anymore, then you got to switch to a different resource. Okay?
But why doesn't it work for video games? Because like people play one video game and they feel like interested every day.
Okay, very good question. Do you think someone will play a video game forever?
Probably not the same one.
Probably not the same one. Diminishing return doesn't mean that it diminishes quickly. right? Sometimes it diminishes a bit more slowly because games they are and there's a different concept. It's called addiction factors, right? They factor that into it, and it's about dopamine. Topic for another day. But basically, games have mechanisms to make you interested, right? So that when you finish the game, you crave for more. But of course, like that craving diminishes over time. So no one plays the game for over like maybe some people play for 10 years. That's a really long time already.
Yeah.
But most of them maybe 2 years, 3 years, or even like a month or two, and you're like bored of it already, right? So yes, the return will always diminish. It may diminish at a slower rate or faster rate. Like when you're eating food, when you get full, you're like, oh, I can't eat anymore. So the diminishing effect is a lot faster. But for playing games, it may be slower, but it's still there, right? It's normally there. Okay, so so it happens as well for video games.
Yeah.
Okay, all right. Any last point for me? Any last question?
If I come here earlier than the time the class starts, is there like another room for me to stay in?
Yeah, you can stay in that one.
Oh.
Yeah, but okay. My previous lesson will always finish at 6:30. 6:30. Yeah, we'll finish exactly at 6:30 or around 6:35 up to there. So how early are you talking about? Before 6:30 or after 6:30?
Probably before 6:30, like around 6 or 6:30.
Around 6 or 6:30?
Yeah.
Then yes, you can stay in that room there.
Okay.
Yeah, and so if I finish with the other class, whenever we're ready, we can just get started with the lesson early, so you can finish early. Because normally we finish at 8:30, but basically today we can finish at 10. I'm just going over time a little bit because I want to go through over these content for you.
Yeah.
Okay, but yes, we can. If you can come early, that's okay. Just stay in the other room.
Okay.
Do you have my phone number?
Yeah.
Yeah. Do you have my phone number?
Yeah.
045111777767. Because I'm not sure if I gave you my phone number. It might be in the online form maybe or in the email. Not sure. But make sure you have my phone number. So I'll just put my phone number here.
Yeah.
Koi 0451177767. Okay. So make sure you have my phone number. Normally the door is open. So I'll just close the door. You can ring the bell. And then I'll just come and open the door for you. Okay, but in case the bell doesn't work, you might have to call my phone number. Okay, but normally if the bell works, just ring the bell. I'll come open the door for you, and you can just sit over there and just either chill or do some work or whatever. Yeah. And then when I'm done with this lesson, then we can get started.
Yeah.
Okay.
Yeah.
Cool. Any last notes?
No, that's all.
No? All good?
Yeah.
Cool. All right. I'm excited to see what you can do. Maybe you'll be my first 99.95 A-class student. Who knows? I'm excited to teach. I always love to teach motivated students like yourself. It will be fun. It will be fun.
What about for English? Is that like another classroom?
Yes, it will be at my house. This is my parents' house. So it will be at 16 Town Street. There will be another classroom. Yeah. That one's a lot easier. You can bus like right there. Yeah. So that should be okay. Yeah, try not to come too early for English. Maybe 10 minutes.
Yeah, I think I arrived at like around 3:50.
Okay. Yeah. That should be fine. That should be fine. That's all good. Yeah, that's all convenient.